Okay, this is a review for MET 171 Test 1. And first thing that I want to do is go over any questions that you might have from the homework. So let's take a look at the textbook and let me know what section and problem that you're having trouble with. Okay? On lesson 1, okay, go ahead.
I have problems with modeling for lesson 3.
Modeling, okay, so that would be lesson 3. Did anybody have anything before in lessons 1 or 2 that there was a question with? No? Okay. Alright, so let's take a look at the modeling.
After that, can we go over the domain of the square root?
Yeah, we can do that. Okay, was there any particular question in the modeling that you had, or was it just modeling in general?
Mine was 23B.
Which one?
23B.
23.
Me too.
Yeah. Okay, now with 23B, you have a river, right? Here's a river. Okay, and then we have a fence, right? And then it goes across, it has like a segment here. Okay, and like that. And we know that that's x, and that's x, right? And with 23, it says, consider the following problem. A farmer has a 2,400 foot fencing. Okay, so we have fencing. 2,400 foot. Okay. He wants to fence off a rectangular feed that borders a straight river. Okay, he does not need a fence along the river. Alright, so really what we have here is what kind of a problem? Is it area? Is it perimeter? Perimeter, right? But the problem with perimeter is that normally we go all the way around, right? We go width and then length, width and then length, right? Well, the problem with this one is there's 2 widths but only 1 length. So we can say that our equation for perimeter, instead of being perimeter is 2 times the length plus 2 times the width, perimeter is just going to be 1 length plus 2 times the width. Okay? Alright. Okay, so let's look at this again. We've got width, right, is x and x. And we have length, right? So we can say that perimeter, we said, was 2,400, right? Equals to the length plus 2 times the width. Okay, well the problem here is that we want to model area in terms of one of its sides, which is x. Okay? And we know that area is equal to length times the width, right? So what we have to do here is we know that the length of the fencing is 2,400. Okay? So if we go ahead and solve for length, okay, for our perimeter, then we can substitute that in. Alright, so here we would subtract 2w minus 2w. Alright, and so that's going to be 2,400 minus 2w equals to, or minus 2w equals to the length. Okay? Alright, so now we want to model our area in terms of length x. So it's like we're cutting that length out, right? And we're putting parentheses there, and we have width. Okay? And so we're going to substitute in 2400 minus 2w. And since we want to model area in terms of one of its length, we need to change the width to x, because we know width is a measurement of x, right? So that's area in terms of x is equal to 2400 minus 2x, and then the other width, that'll be also x. Okay? So at this point, what do we need to do? You can, technically, you could leave it that way, but you could also go ahead and distribute that x, right? And so this would be area in terms of x is equal to 2400 x minus 2x squared. Okay? And that's your model. Alright, any questions with that? Okay, what else? Was there a question with? That one's probably one of the more difficult modeling problems, because it involves perimeter that's not normally used. Okay, what else on the modeling? Well, how about if we were to look at, let's say, we have a triangle. Okay, and in this triangle, we have the base is 4 times as long as the height. Okay? And we want to find a function that models the height in terms of the area. Okay? So first of all, we're modeling what here? Height in terms of area, right? So we want h of a, which means which one's the variable?
A.
A is the variable, right? What is the equation? In other words, what are we going to be solving for?
A. No.
The height, right. So here's our triangle, right? Height, base. Okay, the base is 4 times as long as the height. Well, we don't know what the height is, so the height has to be what? In this case,